Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, so today we are going to start with a new topic of mathematics which is called as rectification. So here we are going to learn what is the concept of rectification, why do we use rectification in integration, and then we'll see what is the formula to find out the length of curve. So these things we'll cover in the coming video. So here let's understand what is rectification. So rectification is basically used to find out the length of curve or the length of arc of the given curve. Now guys, let's say to understand the concept, or let's say to understand the formula, I'll take one diagram, I'll take one small arc, and let's try to find out length of that arc. So here let's assume that the equation of curve is y equal to f of x. So this is x-axis, this is y-axis, and let's say A is a fixed point, and from A to B we have to find out the length of curve, or let's say the length of this arc. Now how to find it out? So let's assume 2 points, one is P and one is Q, between A and B. So let's say that the coordinates of P being x and y, and the coordinates of Q being x plus del x and y plus del y. So del x is the smallest part of x. So it means, let's say it is 1 and 2. If x and y is 1 and 2, so this will be like 1.01, and let's say this will be 2.01. So del x and del y are the smallest part of x and y. So it means we can say that this point Q is very close to P. Now to find out the formula, let's draw the perpendicular from the given point. So from P I've drawn the perpendicular, from P and Q both I've drawn the perpendicular on x-axis. Let's call it as M and N. Next I'll draw one more perpendicular here, so let's call it as R. Now since as we have written the coordinates of Q as x plus del x and y plus del y, so we know that this whole distance, this distance will be y plus del y. Now the coordinates of P are x and y. Here I'll write the coordinates of P are x and y, so this distance is y. So if this distance is y and here this distance is x, so guys, definitely if this distance is y and the coordinates of Q are x plus del x and y plus del y, so this will be y and this will be del y. So this distance is del y. Similarly, if this is x, then this distance will be del x. Now let's say the length of this arc AP is S. So here I'll say let AP is equal to S, or arc AP is equal to S, and let's say this PQ is del S. So it means that AQ will become S plus del S. So here I'll show that this AP is S and this one is del S. Now guys, to find out the formula, we'll assume what scenario. So let's say if Q comes closer to P, then what will happen? Let's say Q is coming over here, so we will get del y here and this will be del x. So guys, it means we will get a triangle. So if Q comes very close to P, then we'll get a triangle, and that triangle would be the right angle triangle, because here this is the perpendicular, so this angle is 90 degree. So it means we'll get a triangle PQR. So that triangle PQR will be the right angle triangle. So for any right angle triangle we can use the Pythagoras theorem. So by Pythagoras theorem we can say that the value of del s square will be equal to del x square plus del y square. Now let's divide both sides with del x square. So here we'll get del s by del x the whole square equal to 1 plus del y by del x the whole square. Now guys, let's say if we take the limit del x tends to 0, and by taking root on both sides we'll get ds by dx as square root of, so this is a root of this ds by dx, and this will be 1 plus dy by dx. So I'm just replacing this del with d. So ds by dx would be under root 1 plus dy by dx the whole square. Now guys, if we integrate both sides with respect to x, so here we'll get integration ds by dx into dx, and here we'll get integration under root 1 plus now guys, here dx and dx will be cancelled and integration of ds will be s. Now here what we are doing is we are finding the length of arc AB. So let's assume that the coordinates of A are x1 and y1 and the coordinates of B are x2, y2. So it means, let's say that the x coordinate of A and B is x1 and x2. So since we are integrating with respect to x, we'll be taking the x coordinates. So here I'll say it is from x1 to x2, and under root we will get 1 plus dy by dx the whole square. So guys, here we got the formula to find out the length of the arc AB. So this is how this formula is been derived. So guys, I'll be taking this formula every time whenever we will have y as a function of x. So to get the answer, we'll find out dy by dx by differentiating that y with respect to x. We'll put that value here, we'll take the square, we'll add 1, we'll find the square root, and then we'll integrate, and that time we'll take the coordinates of endpoints of the curve, or I would say the x coordinates of the endpoint of the curve. So here in this case the endpoints of the curve was A and B. So that is why I've used x1 and x2, since these are the endpoints of A and B, or x coordinates of A and B. So guys, this is the formula to find out length of curve if curve is given as y equal to f of x. Now let's say if curve is given as x equal to f of y. So okay, that's simple. In that case what we'll do is we'll divide here throughout by dy. So by doing that we'll get a formula as so this is the formula. Here I'll write, we will use this formula if x is given as function of y, and we'll use this formula if y is given as function of x. So guys, these are the two formulae if our given curve is a Cartesian curve, because Cartesian curve is always given in terms of x and y. Now guys, let's say if we get the curve as a parametric curve. Now what is a parametric curve? So any curve where x is given in terms of some parameter, let's call it as t, and y is also given in terms of some parameter t. So here I'll call it as f1, here I'll call this as f2. So x and y will be defined in terms of some parameter. So here I am considering that as t, but that can be theta also, or it can be some other parameter. So let's say if we are getting curve like this, then how to find the length of curve? So it's simple. In that given equation, we'll divide by del t. So here I'll show you that here in this equation we'll divide both sides with del t. So we'll get a formula as S is equal to integration from t1 to t2 under root . So guys, this is the formula if our given curve is a parametric curve. So here I'll write, this is a formula for parametric curves. Now guys, we have one more type of curve that is called as polar curve. Now, what is polar curve? So curve given in terms of r and theta is called as polar curve. So you may get r as a function of theta, or you may get theta as a function of r. So in both cases, we'll see what will be the formula. So that time the length of curve is given by the formula . So guys, we'll use this formula if r is given as function of theta. So we have few curves like r equal to a into 1 plus cos theta, or r equal to a into 1 minus cos theta, which we also call it as cardioid. So that curve is a polar curve where r is given in terms of theta. So to find out length of cardioid, we will be using this formula. Now similarly, let's say if theta is given as function of r, so formula will be . So guys, this is a formula which we will use if theta is given as function of r. So guys, here we have seen the 5 formulae, 2 for polar curves, 2 for Cartesian curves, and 1 for parametric curves. So we are going to use this 5 formulae to find out the length of curve in rectification. So I'm sure you understood how I derived the relationship and what are the different formulas for finding the length of arc or the length of curve. So guys, just apply this formula in the examination and you'll get the full marks. So keep watching the videos, because in next video I'm gonna start with the problems based on rectification, and we are gonna find out length of different curves. So don't forget to share this video with your friends, because friend in need is a friend indeed. If you help them out, then they'll also get good marks in the examination. Thank you very much guys.